All right, so this will be an updated version of the walkthrough for Model Creator. So the first thing I'm going to do is go ahead and open up the software. And once it's open, we'll have the splash screen in front of us. So best way to get rid of it is just to click anywhere off of the splash screen itself, and you'll be right here. From here, I'm going to go ahead and import some STL files. So by default over here on the right, this mounting object shouldn't be open, but it is. So that'll be fixed in a later release. But for now, we're going to start at the top. And the idea with our workflows is typically they go from the top to the bottom. So we're going to start off by importing scans. We have STL files, so that's what we're going to grab. So I'll click on that Import STL File button, and these will be located on my desktop because that's where I have them saved to. I've got an upper scan and a lower scan. If I hold down Shift, I can select more than one, and I'll go ahead and click on Import STL. It'll take a moment, and they'll come in. There they are. Now, simple kind of concept here in general in a lot of the workflows in our software is that they depend highly on the alignment of the models to the scene's X, Y, and Z axes. So what that means is that right now, if we look at this, we're looking directly at the Y-axis, like at it from the Y-axis perspective. So this blue line we have here is our Z-axis. The red line is our X-axis. And looking at it like that, we can see that it's out of alignment because the teeth are kind of facing up at an angle. So we need to correct that. We're going to do that not by going to 3px alignment, but by going to model prep work. So once we have that open, we're going to go ahead and go down to click Move Origin to Center Mass. And this is just a simple function that takes these yellow dots and makes sure that they're kind of in the center of each of their respective objects. And you'll understand the importance of that in a moment. And then the next thing I'm going to click on is Toggle Quad View. And what that does is that just gives us this view here that's broken into 4 sections. This top right quadrant is a free view, so we can rotate that as much as we want. We do that by using the right mouse button. We can click the middle mouse button in to pan around the screen and so on and so forth. But this doesn't change anything. This is just our kind of view overall. Then if we try to do that same sort of rotation here on the top orthographic or the front orthographic or the right orthographic views, nothing will happen. And that is because these views are locked in from these different positions on the X, Y, and Z coordinates. So we're looking directly at it from the perspective of the Z, or looking down from the top, looking at it from the Y-axis like we were earlier, and we're looking at it from the X-axis on this one. So what does that all mean? Well, this gives us the opportunity to kind of align these properly. And I'm sorry for the overlay getting in the way of everything over here, but we'll still be able to see what's going on. So ultimately what we're going to do is first, I'm going to rotate the top orthographic by pressing R on the keyboard. R will initiate the rotate function. Notice no keys or anything are being pressed now, and I'm not holding the key down. I just pressed it once, and now I'm in the rotate function. And I'm going to move my mouse. If you notice that it's way too sensitive, you're probably too close to your origin point. So we'll move it a little further away. And I'm just going to line these up so the centrals are kind of facing down on this green line, which is our Y-axis. And then I'm going to use G to grab the objects. So there's G. And I'm just going to move them a little bit to the left so that green line kind of lands right on my midline. That's kind of my goal there. So I'm done with that quadrant. I'm going to look down here at the right orthographic now because I see that if I want to, I can flatten these out a little bit better. Right now they're kind of angled upward. So I'm just going to kind of make that green line, again, the Y-axis, into where I would want my plane of occlusion to land. So I'm just going to rotate this, bring it down a little bit, and use G to grab it and move it up. I'll rotate it back up a little bit. That's pretty good. Now, this doesn't have to be absolutely perfect, but what will happen essentially is we're going to trim away excess data, and then we're going to generate bases on these models. And those bases will then go in the directions of the scene's X, Y, and Z coordinates. So in this case, the Z coordinates. They're going to go up on the Z and down on the Z. So if I have a model that's slanted like this, then I'm going to end up with bases that cut off at a different, like a 45-degree angle, rather than having ones that land like this. So that's what we're kind of looking for. Now, another thing to keep in mind, anytime you make a mistake, you can use Control and Z to undo, and you'll go back to where you were. And if you want to redo something, you can use Control, Shift, and Z, and that will redo things in the workflow. All right, so now I'm happy with the alignment of the models. So I'm going to go ahead and toggle out of quad view. Now the next function I need to do is naming of these models. So we now have a function here. It's working name and dupe and opposing name and dupe. So when I click on the working model, which in this case is my lower, I'm going to click on working name and dupe. And what that does is it'll name this model the working model now. So if we look in our collection, which is this area on the top right, we now have a working model in an upper scan. It also generates this duplicate working model. The reason we have that happen is because when we generate a model out of this, it's going to end up with a solid base on the bottom. And when you're designing in Crown and Bridge, it really helps to be able to see through things and be able to look from the bottom side to see how your contacts are, things along those lines. So this duplicate becomes our working model when we're in the Crown and Bridge workflow. So this is just something to prepare us for later. It also will allow you to go back to the stage if you ever make a mistake later on and you didn't happen to save the file in the right way. So you saved it like too far ahead. From here, I'm going to go ahead and do the same to the opposing. So I'm going to click on the opposing name and dupe. We'll again get a duplicate opposing and an opposing model. So there we go. We have those. Next in the workflow is the trim function. So I'll go ahead and open that up. There are a couple ways to do this. One of them is the paint selection. So if I want to use that, I'm going to go ahead and get rid of my working model here. So I'm just looking at my opposing, and I'll go ahead and click on paint selection. And what this will allow me to do is just come in and basically I'm just going to make a cut line all the way around the model. Just get rid of any data that I don't need to keep. Since this is a single unit FCZ, I'm going to cut a decent amount of the palette out. But if I was doing something removable or something where I need that palette information, I could obviously trim a lot closer to the cutoff of the data. A couple of things to note here. The software isn't going to like it very much if you try to do something like this and you end up with a 90-degree angle like this. And the reason for that is when we go to make the base, essentially what's going to happen is the points along the outside of this line are going to get extruded downward on the Z-axis. And when you have something like this, where it's just a straight line up, sometimes those points end up intertwining and encircling with themselves. So the best way to avoid that is to create a rounded edge. So instead of having this 90-degree cut here, we're going to want to actually make it a little bit rounder, something more like that. I'll just do that over here. There. Now I'm going to get closer, so my tool is relatively smaller in comparison to where it is when I'm zoomed out. And I'm just going to keep, like I said, as much as I can here. Or at least as much as necessary. So this is an interesting situation right here where you have a tooth that's kind of cut off from the scan data, right? So we want to keep some occlusal data from that if we can, because it might affect the bite and the way things sit. So I'm going to try to keep this up here. But what I'm finding is when we have this kind of data that's left over, a lot of times you have to lose some of that. So you end up having to do something like this. So it's not the most ideal situation when the scan data doesn't capture the entire tooth, but you can always kind of cut it in half. And again, it's important that I've got that slope going into this rather than a sharp angle going straight up like that. Okay, so now that that's been done, I'm going to come over to the right and click on cut masked areas right over here. And that will cut any areas that I painted. So now I've got a separation between all this floating data and the stuff that I want to keep. So in order to clean that up, I'm going to click on select parts to keep over on the right, and then click on the model surface, the mesh that I want to keep, and everything else that's not selected will then be deleted when I click on remove extra parts. From there, we can go ahead and relax the edges on this, and that's going to take these points that are at the edges of the mesh, and it'll just kind of space them out and smooth them out a little bit. Notice while I click this, the data of the opposing itself is not getting affected at all. And there we have it. Edges are relaxed. So now let's go on to the working model. So here's the working model. Now, an alternate a function that can be used is the lasso selection. Lasso selection is very useful because it can be very quick. The only downside to this is that you have to be aware of where you're cutting because it cuts through the model. So if I hold this up like this and I do a circle like that, that circle is going to show up on the other side of the model. So you have to be careful of that. But otherwise, this tool is very fast because we can do things like that. And then if I get too close to my prep or anything like that, I can always hold down Control and just draw here. And now I've cleaned that area up. Again, here we have some data missing on the tooth. So it's going to behoove us to make this round and possibly go up on the tooth like this. So one thing to keep in mind when you're doing this too is you always want to look around and make sure that you don't have any accidental spots where you might have marked somewhere you didn't intend to. As long as you're clean, you're safe from those things, and you have a better angle cut than this right here, which I'm going to go ahead and slope that in. There we go. This too, a little bit. There. Then you should be good to go ahead and cut these. So cut mask areas just like before. Now, even though we shouldn't have any floating areas, we're going to be on the safe side here and click on select parts to keep again and remove extra parts. That way we definitely have what we want and there's no floating data or missing vertices that are just like hovering around somewhere. So now we've got aligned models that are lined up to the X, Y, and Z axes. They've been trimmed, and now I've got to relax the edges on this guy here. And now the edges have been relaxed as well. So the next thing we're going to do is create bases on these. So I'm going to open up the base section here. And I've got the lower selected already, so I'm just going to click on create lower base. That will project those points downward along the Z-axis, as you can see right here. I have the option to change them. So right now, if I want to, I can use these nifty little tools here to move things around. I can also size them out. So if you need to create a wider base or something like that, you can. You can even rotate it. So if it isn't in alignment, you can try to make it more aligned. But for the most part, as long as you did your alignment correctly in the first stage, this should be a good result here. I like to extend them down a little bit just to give myself a little room for text, which is what we'll get into next. We'll go ahead and finish that one off. And we'll go ahead and do the upper base. And extend it upwards a little bit and finish the flat base. There's an option for a bevel base as well. I found that it creates an uneven surface on the bottom, but it does allow you, if you're 3D printing these models, a little bit of room to kind of pop them off. But we have other options for that, which I will get into towards the end of this workflow. So now we have two solid models here. If that's all you needed, you can print these as is. So we could export these as STL files and take them over to a printer and print them. That's perfectly fine. But if you want a little more data, in our case, we're going to want to make a section die and we want to have the names on this and everything, then that's what we're going to do next. So next thing is adding text. So we'll go ahead and skip over mounting objects. We'll go down to text creation. First thing I'm going to do is move our 3D cursor. So I haven't talked about this yet, but this little guy right here looks kind of like a life preserver pattern on it. That's a 3D cursor. And that's going to be utilized in several places in this workflow. The way you move it around is a little tricky to learn, but I've got the keys up on the screen to show you exactly what you have to press. So to start off, we're going to go ahead and put text on the upper model here. I like to flip my models around so the flat surface is on the bottom when I'm putting the text on. This is completely up to you, but your view will determine the direction that these that the text kind of comes at the model from. So that can play a role here. Just a heads up. So to move the 3D cursor where I want it on the outside of the model here. I'm going to hold down the Alt key on the keyboard. So it's Alt. And I'm going to right click with the mouse. And that'll move the 3D cursor. From there, I'm going to click on Create Text for Model. And that should allow me to start typing. So we'll just say test model. Might be a little hard to see, but it's there. I'll go ahead and complete the text. And when I've done that, it takes me out of typing mode. And now I have the ability to edit this just like I could the models earlier. Now we're going to use our grab and our rotate just like we did before. So I can rotate this up or down or any angle I want. If I'm having trouble because I get these little like flashes, you see that come up there. Sometimes what needs to happen is the angle of the letters needs to be changed. So if you change your view to looking straight down on the models and you hold, or not hold, but press R on the keyboard, you can actually change the direction the letters kind of impale themselves onto the model from. And sometimes they're not quite perpendicular because your view wasn't, and you can just angle them so that way they are. And then the next thing I want to do is size these up a bit. We found that if you're engraving the text into the models, you have to make them pretty large for the most part, but it does depend on your printer and your material. You might be able to get away with smaller letters. If you're embossing the letters, you actually want to save that for the last step of the workflow, because there are other things that will occur along the process that will basically interrupt those letters and cause you to have to reattach them and things like that. It can be kind of tricky. So for this workflow, I'm going to show engraving. So I'm going to increase the size of this by pressing S on the keyboard. And again, just like with rotate and just like with grab, pressing the key once initiates the mode. You don't have to click or press anything afterwards or even hold the letter down. You just press it once, move your mouse wherever you want to move it. In this case, I'm moving it away from my yellow origin point to make this larger. And once it's as large as I want, I'm going to click to apply it. So just a left click and that'll apply it. So there it is. Now from there, I'm going to go over to the right and I'm going to click on engrave text, and that will engrave it into the model. There it is. Okay, so there's one last thing to note here is that whenever you do this process, there's been a lot of renaming that's been happening to make these steps work. So as a result of that, now we have, instead of a working and opposing, we have a working and a reassign this model. So I'm going to take that, make sure it's highlighted, and then I'm going to click on name opposing model to restore its name back to where it should be. Okay, so for that lower, we have a die to cut out. So we're going to go ahead and do that next. And then from there, we'll come back into this workflow to add our mounting objects. That'll be a base for us to print this onto, which we found to help with retention if you're going to pour a base as well. Just a little like flat base with a honeycomb texture on it to kind of create some mechanical retention with your stone. And then we can also add some mounting pegs. So in situations not like this, where more like quadrants or some situations where you don't have proper support across the full arch, you might need a mounting peg. So I'll show you how those work. And then we could also add slotted blocks, which would be in a situation where you're not going to be necessarily mounting this on a full articulator, but maybe using vertex cups or something like that. So we got a good like workflow for vertex. So to move forward from here, we're going to do the die cutout, which means I need to select my working model, and I'm going to go up here to the top of the screen. This is where our different modules are located. And we're going to leave the models module and go into die creator. So this workflow is a little different. And again, nothing should be open here. That's a mistake of mine that will need to be corrected later. We're going to start with die cutout as the step that we want. In order for die cutout to work, your working model has to be named working space model as it is here. So if it's not, we had added a button here in the middle that will allow you to rename it so it is named working model. That's very important for this step to work. So from here, what we're going to do is go ahead and get rid of our opposing. So these buttons over here on the right in the collection, the one that looks like an eyeball, that will allow you to make things vanish or reappear on the screen. So we're going to go ahead and get rid of our opposing model. So all we see is our working model. I'm going to place my 3D cursor on the working model where I would like the tooth cutout to occur. So I'm just going to go ahead and hold down Alt and press right click, and I'm going to put it right here. And then from there, I'm going to click on this mark die cutout. What that's going to do is it's going to create 2 points. One of them is going to be, it could be somewhere floating inside or it could be on the outside. It doesn't matter. And the other one's going to be right on the 3D cursor. So by default, that second point should be what's highlighted. So if I press G, it should grab it, and now we can see it here on the screen. There it is. And I'm going to place this point somewhere around here. I'm going to grab that first point and move it away from the 3D cursor just to show you what's going on. We have 2 points, and we've got this red line in the middle. The red line is more of a visualization tool than it is anything else, but it does help you kind of understand exactly where your cutout is going and what's going to occur. What's more important are the points themselves, but either way, the line's there to help. So margin marking in our software is very different than any other software I've ever used, in that we're not going to be able to just click points where we want them or draw a line where we want it. Instead, we have to extrude this line that we're generating essentially and build it all the way around. A lot of people compare this step to, like, it looks like an inchworm or a caterpillar or something like that. You'll see what I mean. So it's kind of fun, but it does take some time to get used to. So the first thing you keep in mind is all the keyboard shortcuts I've been going over. G for grab, you know, and in this case, we're going to add one in, and that's E for extrude. So when I have this point highlighted and I press E, it's going to add an additional point at my cursor right here. See, so I still have that old point right there. It's tucked underneath the red line. But now I've got this thing following my cursor. Again, I haven't clicked. I just pressed E once, and that extruded the line to this point. So now I'm just going to click to place it, and I'm going to extrude again and place it. I'm going to do this around the whole tooth. I will not speed up this footage just to show how quickly this can be done, but just I wanted to go slow at first to just show extrude, click. So once you're used to it, you don't have to spend a lot of time. The idea is have your mouse where you want the next point to go and place the dot. Margin gets a little bit ambiguous right here, so I'm just going to stay far away from it as I can without brushing up too much on the adjacent tooth. You don't need a ton of points, but having more points does make the line a little bit easier to edit afterwards. And if you make a mistake, like that one's a little too close, I want to move that out, I can go back, select that point and grab it and move it out. But I always have to remember before I start extruding again, make sure I highlight the one on the end first, because that's where I want to extrude from. If you start extruding from here, just for an example, it'll do this kind of thing, and that will not work moving forward. So make sure this is your highlighted point. All right, so we're approaching where we started here. I'm gonna bring this over here. So when you get close, about here, about this kind of distance, instead of placing another extrusion, we're going to highlight both of these points and we're going to fuse them together. So I'm going to have this one highlighted. I'm going to hold down my shift key and I'm going to go ahead and click on this other point. So that first one I was on before would turn green, and the next one will light up with a white kind of light. Then in order to join those two pieces together, I'm just going to press F on the keyboard to fuse them. And that's what we get right there. One thing for die cutout that I've learned is that you don't want to follow contours quite like this as much. So now is my chance to go through and kind of fix things. So I'm just going to grab points individually. You want to stay as broad of a shape as you can here. You don't want to try to follow the zigs and zags of the material too much. So this is where having fewer points might be a little advantageous. This is a little bit easier to edit the line as you go. We can slide things over, but overall, that should be pretty good. This area is a bit of a concern because it's very close to the adjacent. But I don't know what else we can really do there. Move this up a little bit. We'll put that one up there. You notice I'm clicking in a couple places and nothing happened. So that just means that the points are further away than I anticipated. You know, I'm just kind of estimating about where the points are. You don't have to be spot on to highlight it. You can see how close I was there. You just got to be close, and then usually when you press G, if there's nothing that happens, it means nothing selected. So you're right here. But if I move over a little bit, now I've got one. All right, so something like this should work. So I'm going to now move on to the next step, which will be to extrude the die, and this is going to determine the shape of the die and the placement of it in the model. So I'm going to click on extrude die over on the right. And by default, if you're on a lower, it's going to go up. If you're on an upper, it's actually going to go in the right direction. Doesn't matter, because what we're going to do is we're going to grab these points that are highlighted by default. So the next thing I'm going to press is G, and I'm just going to move them down just like that. You want to leave you know, like a millimeter or two of material down here, at least. That way it doesn't get too thin on the bottom. And it also gives you a little more wiggle room if you're adding in our honeycomb base and everything like that. From here, I'm going to rotate my view to look at it from the distal side so I can get a better view of the direction that the die is going in. So as much as I moved it to center it earlier, I didn't, and move it down, I wasn't able to control its depth essentially on this direction going out to the facial. So I'm going to press G and move it back a little bit. I'm going to look at it from underneath and make sure that I've got good room on both sides. Looks like I do. Okay. Divergent paths here. You can just leave this like that and then edit it to move forward. I have found, however, that I prefer to extrude this line upward. What extruding the line upward does is it allows you a little bit more control over the way the cutout works here. So that's my preference. I will show you the workflow without doing the extrusion because it is an additional step, but just keep in mind that there's an option to highlight all these points and extrude it up and create another like additional layer to your cutter. There's a lot of freedom with this workflow. We'll go ahead and go with it like this. So from there, I'm going to click on die relief settings. It's the next button down in the workflow. And what that does is that first opens up our ability to change the thickness of our cutter. So this red area is now going to be what essentially cuts the model and cuts out the die. So there's going to be a little bit of space in there. We have found in our own workflow with our own printers and everything like that, that a thickness of 0.04 or 40 microns seems to give us a really good fit here. So that's what I'm going to set mine to. I recommend that as a starting point for anybody. I don't know why we still left that at 0.07. That's something that we could fix later, but there's a chance that you need more or less depending on your printer. So it's something you can always make a variable and you can always change it. And we wanted to make sure that was an option. So there it is. From here, we can also notice that we've left the mode that we were in before, which was edit mode and object mode. Those are the modes we've been working in. We are now in sculpt mode. Sculpt mode gives us this toolkit over on the left. And this is all your sculpting tools, which there's a lot of them. We're really just going to be using the default one here, this elastic deform. That's essentially a morphing tool. And we're going to use that to move this red line and make sure that we're not cutting into the adjacent tooth and we're not cutting into the margin. Because as I said, anywhere this red line is, that's where it's going to cut. So probably won't spend a ton of time on this. And it won't be absolutely perfect because I want to be able to move on to the next step for you guys. But this is definitely a situation where I would have preferred to have the extrusion going up because I could control the point. Essentially, one of the main rules with this cut is that you don't want it to be hidden underneath the model material because then it won't cut all the way through. So it needs to be exposed. If you had extruded it, though, this point now becomes a joint at which you can kind of hinge the rest of the cutter, and you can actually keep it below the tissue here and then extend it upward from that point. Instead, I have to drag it up and get it to show above the surface there. That should be fine. Just going to move those out a bit. And again, just as I mentioned before, the broader this circle and the more circular in shape it is rather than, detailed, the better of a cutout it's going to be. Again, this is just cutting out the basically hole in the model for your die to fit in the socket. We're going to be actually fine-tuning the margin after this. So I'd say that should be good. So I'm going to go over here to the right and click on Execute Die Cutout. And that will then cut that red area away. You can see we have a little bit of space in there. And we now have two separate objects as well. We have our working model, and then we have our quote-unquote model object, which is our die. From here, I'm going to move my 3D cursor again. I'm going to go ahead and hold down Alt and right-click on the margin itself. Get a little closer here. We're going to close up the die cutout, and we're going to bring in the fine trimming die step. From here, I'm going to click on Mark Margin. We should get a green line this time. Same rule applies. Start by grabbing. This one I definitely want to make sure I place a few more points on just to make sure that it's easier to edit later. See, when you're placing a bunch of points, you can still get into a groove here. I don't like where that one is. There we go. The more points you have, the easier it is to control, essentially. The problem with more points is that it can become very difficult to maintain. Oop, looks like I made a mistake. So at some point here, I might have accidentally selected all of the points rather than just selecting that one. And what's going to happen here is I pressed F, so it's going to try to fuse all the points together. We'll end up with something absolutely crazy here. All right, so this is actually a good learning opportunity. Everybody makes mistakes, and the good thing about software and anything digital is Control Z and it never happened. All right, let's try that again. So I'm going to click off of both of these points so I know that nothing is selected. I'm going to select this one first, hold down Shift, and select my first point, then press F. That's what you want to see. So if you make a mistake, always remember, just stay calm, don't freak out, don't click a million times because, man, that will overload the system. It'll almost guarantee a crash. There's also something you might notice as you go through the workflow. Occasionally there will be a button that says Save Blend File. That's essentially saving your project that you're working on right now. Now, that said, there is an autosave feature that does exist in the background, but you can't rely on that because you don't know exactly when it's going to apply. It doesn't really tell you that it's autosaving. So it's always a good idea as you're going through the workflow to save because you never know when the software is going to crash. Blender has that happen sometimes. It's not uncommon. So just be aware that it's a possibility before getting too far into your workflow. Okay. From here, I'm going to go ahead and zoom out. Got the margin marked. The next step is to generate a ditcher. So the ditcher file is basically just going to be this angle cut that goes in below the margin and cuts the die so it's ditched. So what we're going to do is first look straight down on the die. That is very important. The direction you look at the die here is going to change the direction of the ditcher. And then I'll create the ditcher, and there it is. Okay, so this is right now just a rectangular kind of band going around it. We're going to change the shape of this by clicking on Ditch Adjustment. I'm going to start by doing just that. So I'm going to click Ditch Adjustment. Clicking it once now brings me into an edit mode where I can move the mouse up and down, and it'll change the way that the object flares out, essentially, the ditcher. I'm going to flare it out just a bit so we get this kind of angle going on the whole thing. And then I'm going to double check along here. If you noticed, before I did the adjustment, I'll go ahead and undo it here really quick. You can see that there are parts of material that are sticking out. If you end up with a lot of those and the ditch adjustment doesn't cover them all, let's say that the ditch adjustment just did this instead, just a little bit. We've got areas like that and everything. One solution to this is to click and select just these points on the top, and then you can edit those points. So that way you definitely have everything cut that you wanted to cut. So what I can do is click off of this so no points are selected. Hold down the Alt key and click specifically not on one of these points, but on the line connecting the two of them together. And that should highlight all the points on the top specifically. From there, I can grab these points with G and move my mouse up. And that can usually get rid of these. If that's not enough, you can also resize these points by pressing S, and you can shrink them in on the die a little bit, something like that. Again, these points down here are right on the margin, so they should be fine. It's not going to affect your margin, but any of that extra material that was hanging out the sides can get covered like this. And that's the easiest way to get rid of most of those situations. Some of them require a little bit more finesse individually. You can always grab just a single point if you want and move it around. So you have a total freedom here in how you approach this cut. But what's going to happen is once I apply ditching, it will then cut into the die and generate for me basically a surface that I can read the margin a lot clearer on. There it is. If you're a little more aggressive with your ditch adjustment like I was at first, you'll get a more clear result, but this is still perfectly functional. So from here, we're going to go ahead and bring the model back in. So we've got our working model. It's got a cutout for the die itself. It's got a little extra space in there where the ditcher is. Everything should be working pretty well here. The next step that we're going to use is a cylinder hole to allow us to eject the die from the model here. So the best way to do that is to close up the fine trimming die step and go to hole cutter. So we're in hole cutter. Now again, just like before, this is going to depend on where our 3D cursor is. So I'm going to rotate my view. So I'm looking at this directly from the side. Try to line it up as best I can. If you really want to, you can start by using the X button here, but then the angle is going to be wrong. And one thing you can do, which I don't have the keys showing here, you can use your numpad over on the right of the keyboard to navigate the scene. And we can use 4 and 6 to rotate our view along that axis that we're currently on. So I can get a better angle on the die like this. And now I know I'm lined up flat with the model. It's just an option that exists, but it's not necessary. You can always just use your view and get it where you want it. Okay, anyway. So let's say we're looking at something like this. I'm going to place my 3D cursor. I'm going to go ahead and click on the die once so I can see its silhouette. I want to aim right about here, somewhere in the middle of the die. So I'm going to hold down Alt and right click, and that's going to move my 3D cursor. Then I'm going to go over here to the right and add a cylinder for hole. It will add a cylinder based on my view. So now I can rotate my view. I can see the cylinder. Now the cylinder by default, it's going to just basically place that cylinder right in the middle of the cylinder, land right where your cursor is. So that means that it's not going very deep into the model. In my experience, we want to extend this inward. So what we're going to do is resize it. Now, size and any other function, rotation, all of these work in general. When you just press the button, it's going to universally change the object just based on your view and based on the object itself. So if I press S and resize this, the problem we're going to have is it's going to get bigger. I don't want that to happen. I just want to extend it along the basically top and bottom of the cylinder. Now, as much as we have a Z-axis that exists for the scene itself, which is what's moving vertically here, you can't see it right now. We just got the green and the yellow, but the blue line. Each object also has its own local X, Y, and Z coordinates, essentially. So when I press S and then I press Z, that first one shows the blue line that works for the whole scene. If I resize on that, that's not going to be what I want either. And I could try to figure it out with the X and Y, but this isn't perfectly lined up with either of those either. So what do? Well, if I press S again and I press Z and I press Z one more time, I switch from being on the global Z-axis and I move it over to the local Z-axis for that object. So it's a lot to take in, but essentially the cylinder's top and bottom of itself, so its head and its feet, are the top and bottom of this. That's its Z-axis, right? So that's its local Z-axis is going to move along the top and bottom of the cylinder, essentially. So resizing it in relativity to the cylinder itself along the Z-axis means that we extend it, right? So that's all that is. Same thing works with the grab function. I could grab it and move it, or I could grab it and move it along the global axis, or I can grab it and move it along the local axis. So it's a little extreme. It doesn't need to be that long, but as long as it goes, I'd say close to halfway through the die, we found that tends to do the best cutting for us. And then obviously comes out here without impeding on the margin or anything like that, then it should be good. So once we're happy with our placement, over on the right, I'm going to click on Accept Cylinder Placement. And now it's there solidly. And then we can cut the hole. Now, my recommendation is to now take this cylinder, click on it once so you can see it highlight over here in the collection. And then we're just going to click on the eyeball for it right here and ghost it out. And the reason I do that is because I want to make sure that this cut function works. At any step along this process, things might not work, and there are workarounds to fix them if that does occur. In this case, I've seen some situations where the cut doesn't do what I expect it to for some reason or another. So make sure that I get rid of it so I can see the actual whole form. Otherwise, you won't see it. You'll just see the cylinder still. You have to get rid of it anyway to see it. So get rid of it, then click on Cut Hole after highlighting the object you want to cut. So in this case, I'm going to cut the model. I'll click on Cut Hole. I should see the whole form in the model. Then I'll click on the die. And again, click on Cut Hole. And I should see the hole go through the die right here where the cylinder was. This one will take longer because there are more faces on the die. So it's more to calculate. And there we go. Now we've got our ejection hole. One last step to this workflow, and the reason that I'm including it is because it's extremely important for Crown and Bridge, is we have to assign the tooth number for this. So this is tooth number 30. So we're going to go ahead and assign that. So I'm going to go to Assign Tooth Number, make sure that the die is selected and highlighted. And then it should give you this chart with a bunch of tooth numbers on it. We're going to select tooth number 30. And there it is. Now what that did is that created a nested little collection for the die. It's called Restoration 30. It has our ditcher that we made. It's got the margin line and it's got the die itself. So those are all stored under there. So they exist in the scene. We can bring our opposing model back in, and we're going to go ahead and go back up to the top and go back over to our models module. In the models module now, this again is a perfectly functional model. You could just print this as is, but if you want to go a little bit extra on it, we can go into our mounting objects. So that's where we're going to go next. So the first thing I want to do here to make life a little bit simpler for us is I want to move the 3D cursor into the center of the scene. And you can do that by pressing C on the keyboard, but you have to hold down Shift first. So Shift and C. And what that does is that centers your view to the center of the whole scene, and it also moves the 3D cursor back into the middle. That way I know I'm kind of working with my X, Y, and Z coordinates here. So this is going to become extremely important as the X, Y, and Z function and moving around the local and the global different positions and everything like that. The first thing we'll import is the honeycomb base. I think that's actually a good place to start. So click on Import Honeycomb Base, and that's going to bring in these two purple platforms here. Now, by default, they're connected together. So if I move them together at the same time. I resize them both. Okay. And if you're ever like resizing something and you don't want to apply it, you can right click instead of left clicking, and that'll snap it right back to where it was, as if you never clicked in the first place. So it's a quick way to kind of get out of a function if you make a mistake. All right. First thing I'm going to do is move this upward. So I'm going to grab it and go on the Z axis. I'm just going to kind of get it close to where I want them to be. Next, I'm going to click on Separate Objects, and that's going to split them apart. So now they're two separate objects. And the reason I do that is because typically they're not quite spaced exactly where I want them to be. So I'm going to allow myself to change that. So let's go ahead and look at this again. We can use this tool right here. We can see exactly what we're doing. I'll grab it and move it on the Z axis. Okay, and I just want it to barely break through, so I'm going to go about there. And to double check that, I can also click on it once, and you can see that line cutting right through the middle of that bar there. That's about where I want it. And I'll do the same thing on this one. Again, look at it like this, so I get that kind of view. You can be either side, it doesn't matter. Click on the model. Okay, so that one's way deep. I want this to be a lot closer to the top, so I'm going to grab this, grab Z, drop it down. Let's move it just a little bit inside. Perfect. I've got contact all the way around, so that'll function. Next, I'm going to highlight both of these objects. So I'm going to click on one, hold down Shift, and click on the other. And that way, any edits that I do to one apply to the other as well. Typically, if you're doing a full arch case like this, you don't need mounting pegs. Mounting pegs are these vertical pegs that we'll bring in next, so you can see what they do. In a full arch case, you would actually work on these individually. I would typically grab one, not grab, but size along the x-axis, bring that in, shrink it a bit, and basically make this fit this one individually from this one, because I'm probably either going to be mounting it on a full articulator or on a vertex, but either way, on either of those situations, I don't need the mounting pegs because I've got full support of the rest of the arch, and I don't have a distal extension here. So because this tooth is sitting in the middle, I've got another tooth supporting the occlusion and the bite, I shouldn't need anything else to mount this properly. But if you do want to maintain the bite for whatever reason, you're going to want to use mounting pegs. So mounting pegs, to bring those in, I'll go ahead and, because my cursor is still in the middle, I'll just import a mounting peg and I'll put it right there in the middle. And again, I'm going to utilize my X, Y, and Z quadrants, essentially, or the axes, to place this object. So I'm going to grab it and move it along the Y first. I'm going to put one right around here. And I'm just looking at really the distance. I want to get the height right, and I want to get the distance from the model correct. I could bring this a little bit closer along the Y-axis, like that. And then I'm going to resize this thing on the Z-axis until it comes into contact with these honeycomb bases that I had there from before. So S and then Z, and that's a little too sensitive. My mouse was too close to the origin. Again, if you keep your mouse away from the origin, it makes these tools a lot easier to manipulate. I'm going to overextend it a bit vertically because the top is a lot closer than the bottom, because nothing's, you know, perfect in terms of distance from the midline there. Not the midline, but the occlusal plane. And I did make my base a little taller on the upper, so that, or shorter, I should say, because then that means that it's going to hit there first. So since I extended it a little bit too much, I'm able to just grab it and move it down on the Z-axis and make sure that it's just touching on both sides. So it's breaking through there, definitely breaking through down here. Okay, so then from there, I can do a Shift and then D as in David, or in this case, duplicate. That's what we're doing. So Shift D will duplicate it. So I've got a second object mounting peg that's sitting in the same exact place as that one. And if I move my mouse, it's going to follow my mouse. So rather than it just following my mouse, I'm going to utilize again the Y-axis in this case, move it back, rotate my view. I'll grab it again, move along the X-axis. And again, I'm looking at the height, which shouldn't change now because of the fact that I'm moving on the X and the Y axes. The height should be perfect. It should stay the same because I'm locking it in. I'm not allowing it to move up and down. I'm only allowing it to move on the X or the Y. GY. We'll get a little closer to the model. That should be fine. And then we'll go ahead and Shift D again, use the X axis, slide it over here. That's pretty close. We can get a little closer, I think. But ultimately, I'd like to keep these equal and parallel to each other. So I'm not going to move it up on the Y-axis at all. I'm going to keep it here. But I can move it a little bit to the right. GX, move a little closer. Okay. So now that I've got those all set in their locations, I'm going to go ahead and adjust the bases now to fit those a little bit better. So highlight them both with Shift. And we'll just do SY. We'll shrink it up a little bit because then we can do GY and move it forward. We can go a little bit smaller if we want. Here we go. And then we'll do SX. I need to make sure that the mounting pegs are still on something. And that the models are good. I think we can stand to move the whole thing over a little bit on the X-axis. So we'll move it a little bit that way. And that'll allow us to shrink it a little bit more. Still got plenty of room on the lower. The upper is getting a little close, but we can move it yet even further. A little bit more to the right. Shrink it down a little more. The smaller these are, the easier they are to work with afterwards. And obviously the less material you're going to be printing. Yep, that's still good. Cool. All right, so I'm happy with that. So now we're going to go ahead and separate our objects. So I'll go ahead and grab my mounting pegs and separate them. And now I've got an upper piece and a lower piece. And you can see that they fit into each other. This one has a cone. This one's got a socket for the cone, which you can't really see through the silhouette, but it's there. Okay. Next is bringing the slotted blocks. So I'll go ahead and bring that in, import slotted block, and there they are. And again, just like with before, I'll go ahead and move them over a little bit here. I'm going to go ahead and separate them and then move them up and down. Now it's key with these to not resize them, because again, these are kind of sized pretty well for the vertex articulators. So I'll move it down. Yeah, I'll move this one down as well. Not quite as far. I'm going to grab them both and move them in on the Y until they're just touching this part of the base. Now, this is where you can get nitpicky or not. Theoretically, if I have this a little bit too high like it is right now, when I go to nest this on a printer, it's not going to automatically try to put this thing flat, right? It's going to put it on this object because it's taller. And I could just shrink this into the platform a little bit and it'll be fine to print. Okay, but if you want to be a perfectionist like me, you're going to get a little closer. Just a little bit. Get a good view of this thing. Grab this one by itself. Move it on the Z-axis. Get it to just this point right here. Now I have to get really close to see any sort of ledge there. I can guarantee you if I go to nest this, it's actually going to nest flat. Just a little extra touch. It does take a little bit more time though. this would have been functional, but this is really good. If you really want to fine tune it, you can grab it, Z, and use the arrow keys on your keyboard to get it exactly where you need it to be. So something like that will work. So, current release, all cards on the table here. We've had an issue occasionally with joining these objects to the models, and it's caused a crash every once in a while. So, in order to avoid that from happening, the first thing I'm going to do is actually do a prepare to print function on the models separately before I join everything together. So this would normally be the last step, but it's going to be this first step. I'm going to go under text creation and click on prepare for cam. I'm going to do that multiple times until the section down at the bottom where it says modified says zeros across the board. So do the same thing on the upper arch here. There we go. And then I'll click on the die and I'll do it there. Now the rest of these objects are simple geometry objects, so they shouldn't be a problem. I have noticed though the bases sometimes have one or two. So we'll do those. Okay, the next thing I'm going to do is save my blend file. There's a save blend file button right here. So I'm going to do that. I'm going to throw it right onto my desktop. So I'll just go desktop, test model. And I'm going to save that as is. Okay. That way, at this point, if this does crash, I can reopen right to that file. I know I have it. Okay, so next thing we have to do is join these things together. The simplest way to do that is to select the objects you want to join. And I recommend doing the mounting pegs, the base, and the slotted block first. And you hold down Control on your keyboard and press J, and that will join them together. I thought I had J on the overlay, but I don't. So Control J, that joins. Okay, so now I've got a base and I've got a model. Do the same thing with the lower arch here. Join those together. Okay. Now I'll go back up to the upper, select the base, select the upper arch, Control J. Still good. Lower. Shift. Select the lower arch. Control J. Good. All right. We have no problems. So the next thing we have to do is export these models. So we've got an upper model and a lower model. So I'm going to select both of those, and I'm going to select the die as well. I don't want to select the margin because I don't need to export that as a separate file. So I just got those three objects. We look over on the right, we've got working die 30, opposing model, and working model. So now what I can do is hit export selected as STL. And I'm going to save these to my desktop, and I'm going to just call them test. What's going to happen here, because we're in this workflow, the model workflow, we have it set to automatically do what's called batch processing. So it's going to just take the selected objects and it's going to save those specifically, and it's going to use whatever we put down here as a naming convention. So what that means is, as a result of this, when I click on export STL, we're going to end up with a test working die 30, a test opposing model, and a test working model all on my desktop. And we'll know it's done because the software will kind of lock up while it's saving until it's done. We'll go to my desktop, we can check. There it is, test opposing model, test working model, and test working die 30. So there they are. That concludes the model creator workflow. Again, many steps in this workflow are not necessary for every single model that you do, but if you want them in there, they are available to you. So thanks for watching.